In 2015, after 9 years and 3 billion miles of silence, a spacecraft the size of a grand piano finally reached Pluto, and the scientists who built it immediately realized their models were completely, embarrassingly wrong. They had expected a frozen, cratered, geologically dead rock sitting quietly at the edge of everything. What New Horizons sent back instead was something that should not exist this far from the sun. And once you see what it found, you will never think about the outer solar system the same way again. 9 years is a long time to sit with a prediction, to build careers and textbooks around what you're certain you'll find. The mission team had run every simulation, accounted for every variable they could imagine. But space has a way of making certainty feel very small, very fast. The first images arrived pixel by pixel, each one tightening the knot in every scientist's stomach. What came into focus wasn't a dead world. It was a world that had been quietly alive the whole time. Most scientists going into the flyby expected Pluto to be, essentially, a corpse, a frozen rock at the edge of the solar system, battered by 4.5 billion years of cosmic silence. No internal heat engine, no geological activity, nothing moving or shifting or breathing on the surface. The models were pretty clear about that. A world that small loses its warmth fast, and Pluto is very small. Smaller than our moon, in fact, with a surface gravity so weak it can barely hold an atmosphere together. What little atmosphere it had was expected to be thin, featureless, and slowly bleeding away into space. The surface itself was predicted to be ancient and cratered, a graveyard of impacts frozen exactly where they landed. Scientists weren't being pessimistic. They were being rational, following the physics wherever it led. And the physics said Pluto was dead, had been dead for a long time, and wasn't going to surprise anyone. The first clear image came back, and scientists genuinely did not know what they were looking at. Stretched across Pluto's surface was a shape so familiar it almost felt like a joke from the universe. A heart. A vast, bright, nitrogen ice heart, roughly the size of Texas and Oklahoma combined. Nobody had predicted it, nobody had modeled it, and nobody had a clean explanation for why it was there. The ice inside it is so smooth it looks freshly poured, which means something is actively resurfacing it even now. Convection cells deep beneath that frozen plain are churning nitrogen like a slow, cold lava lamp in the dark. That kind of geological activity requires heat, and Pluto sits 4 billion miles from the sun, starved of the energy that drives worlds like Earth. Scientists had to stop and ask a question they hadn't seriously considered before. What if the rules they'd built around planetary life were simply wrong? The smooth nitrogen ice filling Sputnik Planitia isn't just sitting there, locked and still. It's moving, slowly churning in massive convection cells, cycling fresh material up from below. That process requires heat, and Pluto, this tiny frozen world, shouldn't have any left. It sits so far from the sun that sunlight arrives roughly 1,000 times weaker than it does on Earth. Radioactive decay in the core could generate some warmth, but scientists calculated it shouldn't be nearly enough to drive what New Horizons actually saw. There are mountains of water ice standing 3,000 meters tall, young enough that craters haven't had time to scar them. There are signs of ancient liquid flowing across the surface, carving channels into the landscape long after it should have gone cold. Pluto is doing things that our models simply didn't predict, and that gap between prediction and reality is exactly where science gets interesting. Nobody expected Pluto to have a sky, not a real one, not one you could actually see. When New Horizons turned its cameras back toward the sun, it caught something that stopped scientists cold. Thin, layered bands of blue haze were wrapping the entire planet in a ghostly, electric glow. That blue comes from tholins, complex organic molecules built when sunlight breaks down nitrogen and methane high in the atmosphere. The same chemistry that might have seeded early life on Earth was drifting quietly around a world 3 billion miles away. And the haze wasn't just one layer, it was stacked, dozens of distinct bands sitting one on top of another. Each layer told scientists that Pluto's atmosphere was circulating, shifting, doing work in ways no model had ever predicted. The air pressure at the surface turned out to be far lower than expected, thin enough to crush most theories about how the atmosphere even held together. Pluto wasn't just a rock with a wisp of gas. It was running its own atmospheric engine, alone in the dark. Pluto's surface didn't look like a dead world. It looked like something had been building. Jagged peaks of water ice rose nearly 4 kilometers above the surrounding plains, rivaling the Rocky Mountains in raw, brutal scale. These weren't gentle hills smoothed by billions of years of erosion and cosmic neglect. They were sharp, young, and geologically fresh, formed within the last 100 million years, a blink in planetary time. Scientists had assumed that a world so far from the sun couldn't generate the internal heat needed to push mountains upward. Pluto broke that assumption without apology. Alongside the peaks, vast nitrogen glaciers crept slowly across the lowlands, filling ancient basins with a pale, rippling texture unlike anything in our solar system. Bladed terrain, pitted plains, and canyon networks carved the landscape into something almost impossible to explain. Every feature pointed to geological forces still grinding away beneath the reshaping a world that had no business being this alive. Pluto broke a rule scientists didn't even know they were enforcing until it was gone. The old assumption was simple. Small, cold, far away meant frozen solid and geologically dead. Every world beyond Neptune was supposed to be a relic, a leftover, a place where nothing had happened in billions of years. Pluto didn't just challenge that assumption, it dismantled it, with mountains and glaciers and a churning nitrogen heart. If a world this small, this far from the sun, can generate that kind of internal energy, then the outer solar system isn't a graveyard. It's a neighborhood we've barely knocked on the door of. Triton, Eris, Makemake, Sedna, each one now carries a question mark where scientists once drew a flat line. The complexity we found at Pluto wasn't a fluke, and most researchers don't treat it like one anymore. It was a signal, broadcast across 3 billion miles, that small worlds have been hiding their lives from us all along. New Horizons didn't stop at Pluto. It kept flying, deeper into the Kuiper Belt, that vast, frozen archive at the edge of our solar system. In 2019, it swept past Arrokoth, a contact binary that looked like two ancient snowballs gently pressed together over billions of years. That single image told us more about planetary formation than decades of telescope work ever could. Pluto cracked open our assumptions, but the Kuiper Belt holds thousands of worlds we haven't even named yet. Each one is a sealed time capsule from the earliest hours of the solar system's existence. New Horizons is still out there, right now, sailing through interstellar space, its instruments still listening. We sent a spacecraft 3 billion miles to a world we once erased from the map, and it rewrote the textbook. The outer solar system isn't a graveyard, it's a library, and we've only read the first page.